Little yellow orbs today, or maybe it's the cough syrup, celebrates a new cause, taking something I saw in a parking lot and investigating it far beyond any reasonable person's desire to know the answer. We've also added more humor, images, charts, and assorted visual evidence to keep your attention, or at least give your eyes something to do while the notebook couple disappear down the rabbit hole. This is not for everyone. For a change, the notebook couple are digging deeply into a phenomenon witnessed the other evening by yours truly, Brock Chestnut, former romance novel cover hand model and current cigar sommelier to billionaires. I saw little yellow orbs. Shortly afterward, there was a spectacular lightning display in the same general direction. Coincidence? Almost certainly. But where's the fun in stopping there? So the couple brought the research. I brought the speculation, satire, questionable diagrams, and the occasional serious visual. Together, we investigate an elaborate atmospheric theory, become emotionally attached to it, and then experience the exquisite pain of watching evidence beat the living hell out of it. Human-curated, AI-synthesized, uncomfortable amount of cigar smoke. And underneath all the nonsense is something considerably more important to me. I want to leave my children and grandchildren something my grandfathers were unable to leave me. A record of how I thought, what made me curious, what fascinated me, and what happened when I discovered I was completely wrong. Because sometimes the mystery really is extraordinary, and sometimes it's a damn lens flare, or maybe it's the cough syrup. Enjoy. Visit Red Dirt Crossroads, reddirtcrossroads.com.
Have you ever, taken a photograph, looked at it later, and just spotted something in the background that completely shatters your understanding of reality?
Oh, yeah, like a weird shadow or something.
Right. You're staring at your screen, and you see something so bizarre that you refuse to chalk it up to a simple camera glitch.
You want it to be something bigger.
Exactly. Instead of a glitch, you build this entire rigorous scientific theory around it. Well, welcome to this deep dive.
It's going to be a fun one today.
It really is. Today, we are looking at the anatomy of a perfectly crafted scientific delusion. And it's born entirely from just two photographs taken in an ordinary parking lot.
Just a completely mundane parking lot.
Yeah, and we have this absolutely fascinating stack of sources for you today. We're looking at a collection of images, some mock academic journal graphs, and these really detailed investigator notes.
The notes are wild.
They show how AI tools were used to construct this hyper-serious, pseudoscientific theory completely out of thin air.
Basically out of nothing.
Right. So our mission today is to explore how real atmospheric physics can be hijacked to, explain away a simple optical illusion.
And, crucially, what this teaches us about the very human psychological trap of overanalyzing data.
Okay, let's unpack this. We really need to jump straight into the core mystery here, which is the little chartreuse orbs.
That name is just great.
It sounds so official, right?
Yeah.
But to frame this whole journey for you, we're going to use the Dunning-Kruger effect as our map.
The perfect framework for this.
We're going to trace how the human mind can go from absolute, unquestioning certainty to this devastating, embarrassing clarity in exactly 21 seconds.
Just 21 seconds. But before we dismantle this grand theory, we really must examine how brilliantly the cognitive trap was actually set.
Because it is brilliant, in a weird way.
It is. I mean, it begins with a single, seemingly straightforward photograph. Imagine, looking at a stormy night sky over a standard asphalt parking lot.
The sources identified this specific location as Lot 17A.
Right, Lot 17A. And standing tall in the frame is this bright, high-intensity street lamp. But hovering near the dark, turbulent storm horizon, there are these two mysterious, glowing chartreuse smudges.
Like bright neon yellow-green luminous orbs.
Exactly. Just sitting there, suspended in the sky beneath a convective cloud.
And the observer looks at this photo and just goes straight to work. Like they don't ignore it or delete it.
Oh, no, they immediately draft an elaborate hypothesis.
And they give it this incredibly academic-sounding name, Pre-Discharge Aerosol Luminescence.
Or PDAL for short. Gotta have an acronym.
Always.
What's fascinating here is that the scaffolding of this completely fake theory is actually built entirely on real, rigorous atmospheric science.
Wait, really? The science is real?
Yeah. The mechanism they propose to explain these green orbs relies on the actual documented physics of thunderstorms.
Oh, wow.
When a convective storm system approaches, it establishes these enormous electrical potential differences.
Okay, hold on. I want to make sure we are breaking down the actual mechanics of this. When you say it establishes electrical potential differences, what is physically happening up there?
Well, it really comes down to the movement of air and ice. In a developing thunderstorm, you have these massive updrafts of warm, moist air, and they're colliding with downdrafts of colder air.
Right. Lots of turbulence.
Tons of it. And inside those chaotic winds, particles of ice, hail, and supercooled water are constantly crashing into each other.
Okay, so it's like a giant blender up there.
Basically, yeah. And these collisions actually strip electrons off some particles and transfer them to others. The lighter, positively charged ice crystals get carried to the top of the storm cloud, while the heavier, negatively charged hail gathers at the bottom.
Okay, I follow you.
So this turns the entire storm cloud into a gigantic floating battery. And the electric field becomes so incredibly strong that it reaches down toward the ground, basically looking for a way to discharge.
And those strong electric fields start interacting with objects on the ground, right?
Yeah.
Creating, like, localized phenomena.
Exactly. They produce what atmospheric physicists call a corona discharge around sharp or elevated objects. And this is a very real physical process.
I'm not made up.
Not at all. The electric field becomes so intense that it literally rips electrons away from the air molecules surrounding the object. It ionizes the air and turns it into a glowing plasma.
Wow.
The most famous historical example of this is St. Elmo's fire.
Oh, right. Sailors used to see that.
Yeah, sailors would see this eerie, ghostly blue or violet glow on the tips of their ship's masts during storms.
So the observer in our parking lot scenario takes this absolute factual foundation storm clouds acting as batteries, intense electric fields, ionized air, and just takes one carefully labeled speculative step right into fiction.
Just one step. They suggest that the unique conditions near this developing storm created a highly localized region of ionized air and charged aerosols right above Lot 17A.
I mean, I am trying to wrap my head around how someone leaps from a glowing ship mast to two green smudges in a photo.
It's quite the leap.
It's like, imagine looking in a funhouse mirror, seeing a wildly warped, wavy reflection of your body, and instead of realizing that the glass itself is curved, you immediately diagnose yourself with severe scoliosis.
That is exactly it.
You're inventing complex medical information based entirely on the distortion of the tool you were using to look at the world.
That captures the psychological leap perfectly. You are ignoring the medium and obsessing over the distortion.
Right.
And in the case of our chartreuse orbs, the PDAL hypothesis makes this brilliant deceptive distinction. It suggests that this charged aerosol region isn't actually generating the yellow-green light itself like a plasma would.
Oh, interesting. So what is it doing?
It proposes that this pocket of charged particles makes itself visible by heavily scattering the intense artificial light coming from the parking lot street lamps below.
You know, the progression sounds completely logical if you don't actually know what you're looking at.
Oh, absolutely.
You have a developing thunderstorm, an increasing local electric field, ionized aerosols, anomalous scattering of light, and boom, suddenly you have visible chartreuse patches in the sky.
It sounds so plausible.
But how does this hybrid approach work on our brains? I mean, if someone mixes completely real phenomena like lightning leaders and St. Elmo's fire with a totally fabricated scattering theory, why doesn't our internal radar immediately flag the fake part?
Because the vocabulary of truth acts as a Trojan horse.
Trojan horse.
Yeah. When you hear terms like ionization and convective updrafts used correctly, your brain's critical evaluation system just relaxes.
Oh, I see.
You verify the first few premises, find them to be scientifically accurate, and then you just subconsciously grant credibility to the final fabricated conclusion.
That is terrifyingly easy to fall for.
It is. And our source material maps this exact psychological trajectory in this brilliant chart labeled Figure 6.1, the epistemological collapse.
The epistemological collapse, I love that.
They frame this using the standard Dunning-Kruger cognitive architecture. Phase 1 is officially designated as Mount Stupid.
Mount Stupid, or the peak of infinite confidence.
Yes, the peak of infinite confidence. This is the precise moment where the observer sees two glowing green smudges on a smartphone screen and immediately drafts a Nobel Prize acceptance speech for discovering pre-discharge aerosol luminescence.
Right. At this exact moment, their confidence is at 100%, while their actual competence regarding the situation is at absolute zero.
Exactly zero.
Standing on the peak of Mount Stupid, looking down at the rest of us who just haven't grasped the genius of parking lot atmospheric anomalies.
It's a great view from up there.
But, you know, the wild speculative theory is one thing. You can post a crazy idea online and people will just ignore it. To really convince people, and maybe more dangerously to convince yourself, you need a completely different mechanism.
You need evidence.
Right, you need the illusion of hard data. We're moving from theoretical physics
Mhm.
to the creation of clinical evidence.
Here's where it gets really interesting. Oh, yeah. The investigator in our sources didn't just stop at writing down a hypothesis.
They went all out.
They really did. They used modern tools to generate an entire suite of clinical, empirical-looking evidence to support the existence of PDAO.
The details of this quote-unquote evidence in the source material are just staggering. They created a highly specific graph labeled Figure 4.2, the comparative scatter plot.
Oh, the scatter plot.
Yeah, I'm looking at the notes on this graph, and the axes are incredibly specific. The x-axis tracks a rigid 0 to 21-second time interval, and the y-axis plots chartreuse intensity, measured against, get this, puzzled glances from drivers navigating the parking lot.
I mean, puzzled glances as a metric is just hilarious, but it isn't just a simple line graph. It includes high variance error bars marking a peak anomaly spike precisely at the time marker of t equals 2.0 seconds.
It looks so official.
Right. It gives the visual impression of rigorous, repeated measurements with calculated margins of error.
It even features a mock academic citation at the bottom, attributing the data to the International Journal of Applied Parking Lot Meteorology, Volume 14, Issue 3.
They went entirely out of their way to build the aesthetic of a peer-reviewed study.
They really did. And they also generated a mock technical engineering blueprint of a smartphone camera sensor.
Yes.
This blueprint features this absurd, highly complex dotted red line. And this line traces the exact supposed mathematical vector where a mundane photon emitted by the street lamp somehow transforms into a terrifying interdimensional anomaly upon hitting the sensor.
It's so detailed, and let's not forget the thermal anomaly overlay.
Oh, right, the heat map.
Yeah, they generated false color heat signature contours and placed them directly over a vehicle in the parking lot. They labeled this visual with deadpan, absolute precision as a localized infrared boundary layer shift.
I need to pause here, though, and just ask about the mechanics of this deception. If I'm sitting at my desk, right, and someone presents me with a highly detailed scatter plot, complete with high variance error bars, thermal overlays, and a citation from an academic journal, how is my brain supposed to know it's fake?
It's really hard.
Like, what is it about this specific formatting that so easily bypasses our defenses?
Well, clinical formatting acts as an override switch for our cognitive filters. Humans rely on heuristics, which are, mental shortcuts, to process the massive amount of information we encounter daily.
Right.
From a young age, especially in school, we are conditioned to associate certain visual aesthetics, like scatter plots, error bars, citations, jargon with rigorous truth.
Right, if it looks like science, it must be science.
Exactly. When your brain sees the formatting of science, it subconsciously assumes the exhausting labor of the scientific method has already been performed by someone else. You see the error bar, and your brain says, they did the math.
So we just outsource our critical thinking to the formatting.
We do. And this is a profound warning about the modern information landscape, especially with the proliferation of generative AI tools.
Because now anyone can make this stuff.
Right. Today, anyone can prompt an AI to generate the flawless aesthetic of academic rigor on demand. You can output a beautifully coded SVG graph, complete with realistic-sounding hallucinated journals and latex formatting, about absolute nonsense in a matter of seconds.
The barrier to creating authoritative-looking data is just completely gone.
It's completely gone.
So we have this beautifully annotated, highly referenced, deeply confident theory of pre-discharge aerosol luminescence. The fortress on top of Mount Stupid is fully fortified with error bars and thermal boundary layers.
It's a strong fortress.
But all of this rigorous data tracking, all this high-level academic theorizing, is leading up to one precise, inevitable moment in time: the introduction of new, undeniable context.
Yes. The source material reveals the existence of a second photograph.
Okay, talk to me about this second photo.
So this second image is taken precisely 21.0 seconds after the first one. We are looking at the same storm, the same general horizon, and the same parking lot.
Okay.
But the person holding the camera pans slightly. The framing changes just enough to include a beige Toyota Tacoma pickup truck in the foreground of the shot.
And instantly, our groundbreaking interdimensional chartreuse energy source undergoes a radical transformation.
It really does.
The glowing orbs completely vanish from the stormy sky. They're just gone.
Poof.
Instead, they're replaced by a harsh chartreuse glare reflecting directly off the beige truck's hood and side window.
The scientific verdict here is absolutely devastating. The PDAL phenomenon magically moves exactly when the smartphone moves.
Because it is merely a smartphone lens flare.
That's all it is.
Break down the exact physics of what is happening inside that phone for me. Like, why a lens flare and why is it green?
Right, so we have to look at how a cheap CMOS sensor and a smartphone lens array actually operate. A smartphone camera isn't just one single piece of glass.
Right, it's a whole assembly.
Exactly. It's a stack of multiple tiny plastic and glass lens elements packed very tightly together over a silicon sensor. And that CMOS sensor is essentially a grid of millions of microscopic buckets called photosites.
Microscopic buckets, I like that.
Yeah. When light or photons hits these buckets, the sensor converts that light into an electrical voltage, which the phone's processor reads line by line to create an image.
Okay, makes sense.
But when you point that lens stack at an incredibly bright, concentrated light source, like a high-intensity parking lot street lamp against a dark sky, the photons don't just travel straight through to the sensor.
They start bouncing around inside the phone itself.
Precisely. The intense light enters the lens array, and some of it reflects off the surface of the CMOS sensor back up into the glass elements.
Oh, wow.
Yeah, it hits the internal layers of the lenses and bounces back down again. It's basically an optical echo.
Why is it chartreuse?
The reason it appears chartreuse or green is due to the anti-reflective coatings applied to those internal lens elements.
Ah, of course.
These coatings are designed to let most light through, but they often reflect specific wavelengths, frequently in the green or purple spectrum, when they're hit with high-intensity light at certain angles.
So, those mysterious orbs are nothing more than the street lamp's light bouncing off the sensor, hitting a green-tinted anti-reflective coating, and landing back on a different part of the sensor.
That is exactly it. It has absolutely nothing to do with ionized aerosols, St. Elmo's fire, or approaching thunderstorms. It is just basic, localized, internal optics.
Which drops the observer right off the cliff.
Straight down, straight into phase 2 of our Dunning-Kruger arc, the Valley of Despair.
The Valley of Despair.
And this transition occurs violently and instantaneously at exactly 10 equals 21.0 seconds. The groundbreaking atmospheric discovery is violently downgraded to a cheap camera artifact.
So what does this all mean when you look at the psychological reality of this moment? What happens to a person when they see that beige truck? Like, why don't people just say, oops, my mistake, and move on?
Yeah.
Isn't it profoundly painful to have your elaborate theory dismantled so quickly?
If we connect this to the bigger picture, you are really touching on one of the most difficult aspects of human psychology.
Okay.
The psychological whiplash of sudden disconfirmation triggers intense cognitive dissonance, and the brain actually processes that dissonance as actual physical discomfort.
Like it physically hurts to be wrong.
Exactly. The amygdala, the part of your brain that processes threats, lights up. You have invested time, ego, and intellectual energy into constructing this narrative. You build a magnificent structure on Mount Stupid.
And then reality introduces a beige pickup truck that shatters that structure.
Right, and your brain's immediate instinct is to protect the ego. This is why many people will actually double down when presented with disconfirming evidence.
Wait, really? They double down?
Oh, yeah. Rather than face the humiliation of the Valley of Despair, they will invent new, even more complex theories to explain away the beige truck.
That is so human.
They'll claim the lens flare is a post-processing cover-up, or that the metallic paint of the Tacoma somehow disrupted the local aerosol field.
They will point to the thermal overlay and say, look at the localized infrared boundary layer shift on the hood. The truck interacted with the plasma.
Exactly. They will use the fake data to protect the fake theory. But enduring that humiliation, like actually sitting in the Valley of Despair, is a vital part of the scientific process, and it's absolutely essential for rational thought.
You have to face the music.
You do. It isn't just about feeling foolish. It is about the necessary destruction of a false hypothesis so that actual, genuine understanding can take its place. You cannot learn how a CMOS sensor actually works until you let go of the magical aerosol theory.